Hey, it's Norm from Tested.
And Sean from Tested.
Sean from Tested here in San Francisco. We're trying something new this week. So longtime fans of Tested will know that we used to run a series called Print the Mystery Object. Every Friday, it's Friday, Will would take a 3D printer, whether it's the printer bot, the maker bot, or even now the Ultimaker, and download something from a resource like Thingiverse. Print it, we'll watch it in time lapse, and have you guys guess what that is. Well, we retired the series because things were getting a little complex, and we printed a lot of the great things already. Plus, we also wanted to make our own things. And so that's why we've brought Sean in. Now, Sean, as you guys may know, winner of our Inventor contest several years ago, also a designer, and you've modeled, your expertise is fabrication, rapid fabrication.
Yes.
So today, we're actually going to talk about a project that Sean has been working on for a while and assemble it and show you what it takes to assemble something and design something to be made with 3D printing.
Yes.
So what is this project?
The working title of this was the Scuttlefish. It's actually a project that I did for, it started out at MakerBot. They were doing a proof of concept for like an animated movie using 3D printed objects. So they kind of wanted to get out the whole like the toy line, basically. So they did a lot of figure sculpts and vehicles and sidekicks and all this kind of stuff. And they tasked me with designing a submarine that would prowl the Gowanus Canal in Brooklyn. The Gowanus Canal is notoriously a polluted waterway in Brooklyn. And so this was kind of like the bad guy's vehicle that was, I think the thing was he was looking for a lost city that's underwater. Oh. So they asked me to design this, and they really liked my octopod, and they wanted something like along those lines, kind of like steampunky, you know, and the octopod is just far too complex to print on an FDM home printer. So we wanted to get something in that spirit, but it was a little bit simpler to do.
And that amazing Octopod project, you used 3D printed rubber, the tentacles articulated. This aesthetically has similar elements.
Yes.
I love the idea of the Scuttlefish. And let's talk about that design process and also assemble it. So let's just get to assembly. You're going to be working on the main body of this, which is multiple colors, different parts, printed on different machines, which we'll talk about. And do I get something to do as well?
Yes, you're going to be, I did an actual display platform for the monster. So you're going to be putting together the platform, and then we modded it to also have one of our tested badges on it from when we did the name tags.
Nice.
Yeah.
These are highly coveted
yes, they got some
things. It's the tested badge, which we've worn at events.
Yes.
You can affix a magnet to it.
Yeah.
They're not available right now
at this time,
but we will discuss it, and maybe something that fans out there will really get a 3D printed tested badge. It's awesome.
Yeah.
I can't wait to get started. You obviously have a much more complex thing to assemble, so let's start with what are the parts and how did you go about designing something to be assembled?
So, well, in comparing, when we talk about the mystery object was typically, due to the way you had to do it, it was like a print it and leave it kind of thing. So typically the mystery object, and I think a lot of what people 3D print is like one big piece. Which is fine, and you can totally print things out like that. But when you do one big piece like that, not every part is going to print in its optimal orientation. So some pieces are going to look really good on it. Some pieces might not print as nicely due to the way they're oriented. And then you're also stuck to one color. So a lot of what I do when I'm designing stuff is I break it up into multiple pieces. Both for being able to print in multiple colors, which I like, because as much as I love building stuff, I hate finishing work. I hate sanding and painting and all that kind of stuff. So with the 3D printing, I like to approach it like, well, if I have 5 rolls of color, it'd be nice to be able to print in all those different colors. So that's part of the reason the monster was designed like this. And then the other reason it's broken up into many pieces is it optimizes its printing orientation. So something like the tentacle here, you don't want to necessarily print it laying down like this because round objects don't print really well on FDM on this kind of angle. You'd want to print it more like this, so that it's drawing circles going up and up and up, because it can draw a circle really well from above like that. So, you know, the tentacles were broken off to be not only so they could be posable, but to print well. And then, so like the body, the same thing. If it printed like this, you'd run into a few problems. You run into it's curved, so it wouldn't print the nicest resolution going like this, and you'd have to fill in all of this area with support material to hold it up.
Right.
Or this would have to be a solid piece, which would waste a lot of material and really increase the print time. So by putting them up like this, it both gives you better resolution on the axis here, and you don't have to. I didn't have to use any support material for this.
And that is a limitation of just the physics of FDM printing, the layer by layer gravity, the structural stability as the plastic cools. When you're designing this, what software do you use to model it?
I'm still using a program called Cinema 4D, which is mainly it's geared more towards like motion graphics, animation, gaming, like that kind of modeling. You could do something like this in CAD as well, because there is a lot of precision, because everything needs to be measured and fit together right. But I've made what would be called a polygon modeler work very, very well for this kind of design. So,
right. So what's the first thing? What are you going to glue together?
So you're going to be putting together the platform. So when I did this, I put little keys and guides to show you how to put it together.
It says F right
because
there.
the cradles are actually cut to perfectly match the bottom here, so that it sits nicely. So
this is going to be super simple for me.
Yeah, you're going to
go ahead and start assembling yours,
and we're going to be doing the monster. So I was saying I started 3D printing back when the support materials that the programs generated were not very good. They left a lot of marks on the thing. They were often hard to remove. And so I got into the habit of designing things to print without support material as much as possible. And I just automatically default to that, which I don't think is a bad thing, because I think it makes you think more about the design, and it's kind of like a brain teaser, like how can I do this without doing the support? And without doing the support, you cut down on how much material you use, and more importantly, you cut down on the print time. Now, having said that, some of these parts do still use the support material. So for example, the head, which prints in this orientation, it has a collar that the body fits into. Right? So because I wanted to hide the seam.
So this isn't one big model in Cinema 4D, you're actually already splitting it up at that point.
Yes, yeah. Some parts, like the body, might start as one piece, and then I'll split them afterwards. So it varies. So the head has this collar that the body fits into, and to hide the seam, I wanted this recess. Now with the recess there, you run into the problem that it creates an area that does need support. So you can see here, this did print with a little bit of support material, but not that much. And it's easily removed with like a pair of pliers or an X-Acto knife or whatever. Now this right here I'm leaving because it doesn't interfere with the collar, and I don't need to mess with it. And the way I also approach this is I try to design them so they don't have to use any glue, or as little glue as possible. Sometimes that's unavoidable. So I generally use pins. So I print out these little tiny pins that everything kind of slots together with. So if you look at the body, it has the pinholes that this goes into. And the reason I use the pins rather than integrated into the body itself is that if the pin was already in there and printed like that, this would need support material to hold this pin. So I just do recesses that the pins go into afterwards. So having said that, we'll do, so we have our special edition and tested colors go on this monster here.
Nice.
So, which is part of the nice thing about doing the multiple pieces. So we're gonna start with the bottom shell here, and simply insert a pin. Now this can be glued, but for the most part, it does stay together fine without any glue. And I left it hollow inside, not only to cut down on the material used, but to allow you to like do some mods, like if you wanted to install some lights or some electronics or something inside. Which somebody on Thingiverse already did a really nice mod where they cut out the windows and the eyes, and they did a really nice lighting upgrade.
Let's also make it clear, this is a model that not only did you design, it is available online.
Yes.
People can download this right now as you're watching the video and print it out and assemble it.
And this is your assembly guide. Bold machine. So I should also give the rest of the story. So MakerBot got bought by Stratasys, and during that period, there was a lot of like changes and things going different. And Bree stepped down as the CEO, and he went on to found another spin-off called Bold Machines. And Bold Machines is kind of like an innovation workshop where they are doing anything from doing mechanical hands to stuff for an animated movie. And so the Gowanus Monster, and it's the Margot series, so it was the Margot movie, got moved over to Bold Machines as well. And actually, Bold Machines has since broken off from Stratasys completely, and their own separate entity now. And Bold Machines have been great with working with me for posting this stuff, and they let me. I have some of these on my Etsy store as kits and everything. So they've been really, really nice to work with.
Nice.
So yes,
got the pins in.
So I got the pins in, and then we have the mid-body fin, which then just sits right on top of the pins. And once again, this was the fin was broken off not only to optimize the printing orientation, but to allow you to print it in different colors. And then we have the top body, and the top body has cutouts for a top fin and all the portholes. And that simply goes on the pins. So it just kind of snaps together.
Now this is also printed on multiple machines.
Yes.
Even though you designed it in collaboration with MakerBot at the time.
Yeah, so I have my MakerBot 2X at home, which is working great. And this is about half and half. About half of it was printed on my MakerBot at home. And then because we'd gotten the Ultimaker 2 at the time, so we were like, well, we should try it out and put it through its paces. So I printed the main body on the Ultimaker 2, which turned out great. So like it's a little mix and match. We got a little bit of everything. We got some PLA and ABS parts in here, and it will print fine in any plastic at all. So
any recommendation for resolution?
This is all printed at 0.2.
Okay.
Which for this is about 13 inches when it's done. So 0.2 resolution, I think is more than enough for this. You could totally get down to 0.1 and it would look absolutely gorgeous, but it'll take a long time to print.
That's right. How long did this take?
I think doing all the different colors and everything, this ends up taking about 12 to 16 hours to print, depending on your settings.
Got it.
All right. All right. So we got the body put together, and we're going to move the head. Now I've already moved the support material that was in the way of the body fitting in. I left this in the middle because it doesn't really matter. Now this is interesting to point out because the only place that this truly needs support is right here, here, and here where the pins go in. It needs the support to accurately draw the little square recesses. Now, an interesting thing is, depending on how your slicing software works, and if you put this piece in 3 different slicing softwares, it could come out totally different as far as support material.
That's right.
So this was actually designed about 2 years ago when it was still with MakerBot, and the software at the time, the MakerBot software at the time, would only put support underneath these little pinholes, which was perfect. They have since updated the software probably 5 or 6 times, and the newest version puts support under the whole thing. It's just something changed in the algorithm or how they did it. So it's like, well, that's a waste. I don't really need support under everything. I only need it under the pinholes. So the trick was, if this was how it was oriented on the print bed, I simply rotated it about 5 degrees, and then it looked at it differently. And by just rotating it 5 degrees, it went back to only putting support material under the pinholes. So and it just has to do with how it's going to draw the plastic and where it thinks it needs support and where it needs held up. So that can vary from program to program.
Yeah. Any slicer you recommend?
I've recently been using Simplify 3D, which is really, really good.
It's worth the cost.
It is. It's $150, which sounds crazy. And the one gripe I've had with Simplify 3D is there is still no trial version. But they stand behind their product, and they're like, if you're not satisfied with it, they will give you a refund. Cool. I think that is still valid.
Yeah, that's a great policy.
I bit the bullet and I bought it, and it is a very good program because not only can you can change You can add supports and then modify them, which is unusual. So you can add your own supports or even take away supports. So if Simplify 3D filled all of this in, I can be like, no, take it out from here and here and here. The other really nice thing, which is unusual about it, is that you can tell it to print maybe the head at 0.2 resolution, but the body, which is also on the print bed at 0.1.
At the same time.
On the same time. And you can even, if you take the time to do it, you can even do something like print the head at 0.2 up to here, and then after that, print it at 0.1. So you can even vary the info and everything. It's like a powerful program if you take the time to do it.
That also really changes how you think about designing the object, where the fidelity really needs to be.
And that's not going to be for everyone. It is $150. I printed a lot of this stuff, slicing it in MakerBot Desktop and the Cura Ultimaker 2 software, and those turned out fine as well. So it kind of depends on what you need to do.
All right, what's next?
So we're going to put the pins in the head here. Now, I have found you don't always need the pins in the head. Sometimes the collar will fit the body nice and snug, and these aren't necessary. So kind of, you just have to do a test fit and see how it works. But for our purposes, we will do that. So you gotta it's a little tricky getting all of them lined up.
Yeah, so when you're designing something also to be test fit, things have to be pretty accurate. You can't have a lot of variation and all these plastic grows and stuff like that.
Yeah.
And so how much margin of error do you put in there?
It's really tough. In fact, I think I got a pin that's a little, oh, nope, there it goes.
Aha.
My baseline for tolerances on this kind of stuff is I usually start with 0.2 millimeters. So if the pin is 3 millimeters wide, I will make the socket 3.2. And that's usually a pretty good starting point. I may have to adjust that up and down a little bit depending on how tight the joint is supposed to be. The other problem you run into with FDM printers, it can vary wildly. Like if you have, when you level the bed, and leveling the bed deals with you bringing the nozzle down to a certain distance, and say you got the nozzle set a little lower than normal, so your first layer ends up a little fat. And so what'll happen sometimes is so say if you're printing out a square, it'll come down and it'll flare out a little bit at the bottom.
Right.
So that flare then can really change how these pins print, for example. So I try to get it in the ballpark, but if you print it on 3 different printers, it can print 3 totally different ways. So it's tough. So sometimes, and when I'm doing the kits, like when I put kits up on my Etsy store and stuff like that, I try to be very specific about the fact that these are 3D printed and there's some play that's going to happen, and you're going to have to do some trimming with an X-Acto or some sandpaper,
totally,
stuff
that's
like
not
that.
unreasonable at all.
So yeah, I mean it's like, and that's like true of any model kit, whether it's you're on the sprue traditional kit or a resin kit or anything like that. So it's not that unusual. Okay, so we got the collar fitted into the body here. Now I have the head does have a few other supports where the engines go, so I'm going to just break these out with the pliers. And support is generally pretty easy to remove. It comes off relatively easily. You can use a pair of pliers. You can then use an X-Acto knife to kind of scrape out the excess. Emery boards, I know Adam's a big fan of. He has a nice collection of emery boards. Those are great. If you can get all different grades of emery boards, like at a good beauty shop, and
you have a good grip and just start shaving away.
I really like using those on my 3D prints. They work really well. Another really good tip is typically when you print out stuff, you'll get the side that faces the print bed. Like you might have. If you're using ABS, you might have the ABS slurry, which is basically ABS melded in some acetone, and that is like your stick solution to get it to really stick on the bed. Or you might use the glue stick like on the Ultimaker. And what that will do is it'll often leave like kind of a mottled appearance on parts on the bottom, particularly dark parts like black and dark gray and stuff like that. I have found that the Magic Eraser works really well on just cleaning that up. If you go over the bottom of that piece, it'll kind of even it out.
Oh.
So I did that on some of this stuff. So, let's do, we'll do the portholes next. So I designed the portholes. Once again, they could have been modeled right into the body, but I wanted the option of being able to print them in different colors. And then I went the extra step and I made a little insert so that it's not gonna just, because you don't want it to just be all one color like that. You want it to look like there's a window in it. So there's little inserts that simply pop in. And this is a really good example of these just kind of snap fit in. They don't really even need glue, but depending on the printer that you're using, you may need to clean these up a little bit with a knife or emery board. And you might, or it might be even a little loose and you use a little spot of glue. So like this guy, this particular one's a little tight. Yeah.
I'm really impressed by just the snap fit and how easily things come together. It's really, you're designing a kit. It's not as simple as just, you can be a fantastic modeler, but you need also have the spatial skills.
It does get a little more complicated when you start making it assemble, yeah.
Yeah, and think about user experience.
Yeah. And Jackie or Valcro, who did the really nice lightsaber.
Yes, we assembled that last year.
He did that for Ultimaker, and he did a really nice write-up on why. So he did two versions. He did one that kind of prints in very few pieces. I think it was like 4 pieces. But then he did another version of the same lightsaber that is 14 pieces. And he did a really good write-up on why he did that, and it all has to do with optimizing the orientation that allows you to, get the best print possible for each piece. And that's kind of the way I approached this. This one just does not want to fit. Okay, we'll set that aside. We'll go ahead and put these in. So a lot of these just kind of friction fit. Based on how these feel, I think I would ultimately put a little glue on these guys. But they're fitting pretty good right now. Let's see if I can get this cleaned up a little bit.
Hey guys, I've made a tested logo.
What?
What? It looks awesome.
We've got a lot of mileage out of that tested.
Yeah, this is fantastic. And you can scale this up.
Well, that's how we did the laser cuts on it.
That's right.
Yeah. That was the same files.
Yes. Yes, yes, yes.
All right, so we got our portholes in, so it's looking good. Got nice testy colors. I think we'll do the eyeballs next. So once again, these are cages that, and I just kind of made these where you can put them on and orient them however you like. But once again, I wanted to make it so that you could do different color windows if you want. So I made these little inserts that you can print in whatever color that so if you want an evil Gowanus monster, you could print these in red or whatever. So this particular piece, sometimes these will snap fit in, and then sometimes I need to glue them. So let's see how they go.
Glue is all yours.
Yeah, I'm gonna use a little glue on this.
Fit. There it goes. Aha.
The windows are a good example of really vary from printer to printer how they fit. And I'll try not to glue my fingers.
Anything else I can do to help out over there?
You can put the pins in the tentacles.
Yes.
So basically we used snap pins, which are great. Those are actually, I have to give credit to WPH Thomas on Thingiverse. He did those really great snap pins actually for, if you've ever seen the really popular geared cube that is really popular. Yes. So he designed those for the PLA version of that. So I rather than reinvent the wheel, I just borrowed those because they're under Creative Commons, so it was not a problem.
Let's see.
So I would have loved to have done fully articulated tentacles for this, but time and budget just wouldn't allow for it. So I did a compromise where we did a pin that allowed them to rotate so you get a few different positions.
And it's great that someone else's mechanical design you can just adopt.
Yep.
Because it is Creative Commons.
That is the really nice thing about the giant community of 3D printing and 3D printing models is that you can, a lot of what I've done on Thingiverse has been like finding somebody's thing and modifying it to either suit my purposes or you know, make it better in some way, or you know, and it's nice that you can share that like that. So we're just gonna glue the eyeballs on.
Mm-hmm.
We'll put it, I think we'll do a little bit of an angle so they look like just ever so slightly menacing.
Yeah. And I know you say you don't like the finishing process, but if you were to finish this, or how other people decide to finish?
Yeah, you could paint this like any plastic model. Like so, any of the stuff like you and Adam have done, you could use the same painting techniques on. The one trick with particularly FDM printing is that you do get the print lines, and the problem you run into with that is, like, let's say we wanted to print the, or we wanted to paint all the rivets on the monster here. Due to the print lines, they tend to have a little bit of a capillary action, so that it'll grab that paint and suck it to other places that you don't want it. So I have found you can do a little sanding on it to kind of reduce the print lines, which can help. And often I find just doing a layer of primer on it can help as well. That will kind of reduce that as well.
For that same reason, you really couldn't do like a wash on this. You would just accentuate those print lines.
Yeah, but sanding it, primer, I've also used Bondo glazing putty that you can kind of smooth this. Now this would be a case that would be a little tough, because if you did that, you'd start to lose your rivets.
Yes.
But you know, on different models, it can work really well.
Yeah.
So, oh no, I got glue on the mat.
That's okay.
I'm gonna borrow these tweezers. So we're gonna put the propellers in, and I designed the propellers that when you assemble them, they can still turn, which is fun. So there's a little socket down here, and it is a little tricky. You do tend to need some tweezers. There we go. And as you can see, this one's a little tight. It might not turn. That one's not going to turn. Okay. But once again, I did this so both these propellers are tricky to print, and I did these at 0.1 resolution, and so they kind of have to print by themselves so that they can print nice and slow. But it also allows you to make different color propellers. Once again, see if this one turns. Yeah, that one turns a little bit. All right, so this is one of the few parts that does need to glue on. I just couldn't figure out a better way to do it. But it's still kind of a snug fit, so it kind of holds in place while it's drying.
No clamps needed.
In theory.
Oh, we're getting close.
Yeah. All right.
Spine?
Yeah, we get it. So the spine was made to slot in both for so it could lay down the print nicely, but also because you could switch this out. So if you wanted, this is kind of the aggressive sawtooth spine that rips through kayaks. But you could, you know, if you wanted something different, you could design something different and put it in there.
Cool.
So,
all right.
So and Norm has, so the tentacles. We should talk about the tentacles. These were very difficult to print, and I knew that they would be because I wanted to be able to print these without support material.
Yeah.
So it was a really fine line of getting these on a curve that would print okay without supports.
Yeah, the overhangs, it's a gradual overhang.
Yeah, so if you do a gradual overhang, like usually, if you're doing ABS, it's usually about 45 degrees you can get away with. And then with PLA, I think it's 65.
Okay.
These were still difficult to print. And so what I found is, so your basic instinct is to just lay these flat on the print bed like that. And what I found is I would end up putting them at a little bit of an angle, more like that, so that it would kind of average out the, like it would kind of make it as straight up and down as possible. So I do that in each axis. So rather than straight up and down, I do kind of like this, and I would use a little support material under here, which is fine.
You can just snap that off.
Yeah, it just snaps off, and they printed pretty well then. This, you can see here, it got a little bit of wrinkle right here where it didn't quite get the overhang. So that I will admit that these can be challenging to print on some printers. And so basically we just have sockets in the head here.
Yep.
And these just snap fit in, like so.
Bam.
And they're designed, you can put them in any order. They don't have to be put in any particular.
I like it.
Whatever.
Oh, so Cthulhu-like.
Yeah. And so this is basically, the octopod was obviously based off an octopus. This is based off of a cuttlefish.
Yes.
So therefore my working title of the Scuttlefish, which I thought was nice. So
that's his mouth.
Oh, let's turn around so you can see that. Yeah.
Look at him come at you. You don't want to see that thing come at you. And the stand. Ha-ha!
Yes. Look at that.
Look at that. And does it fit on top? There we go.
Oh, that's nice.
That's fantastic.
Yeah, the tested size is nice.
Yeah, there you go.
So that's the Gowanus monster.
Sean Charlesworth Scuttlefish. We'll glue that in.
This one needs a little trimming.
Yeah.
Yeah. So done for Bold Machines. They released the files for free along with all the other Margot series. They have some really cool scooter and a dog with a jetpack and characters, and they're all in Thingiverse. If you search for Bold Machines, it will come up. And the Gowanus monster is on there. I have some kits in my Etsy shop if you don't have a print.
Awesome. We'll include that link below as well. Thank you so much, Sean, for bringing this project in. And like we said at the top, we're going to be doing more projects, 3D printed projects, rapid prototype projects with Sean, experimenting with different printers as more printers come in. Yep. You'll be doing some taking projects that other people have designed, really complicated ones, and showing the assembly and what your thought process on that. So if you have a 3D printer or you're interested, then please subscribe and stick along. And if you have ideas for what you'd like to see Sean design and print, we can get that done.
Yeah, because I can't do one every month, but if you come across a really good model, we already have some in mind, but if you find something good.
It's going to be very exciting. Thank you so much, Sean, and thank you guys for watching. I'm Norm.
I'm
That's
Sean.
And we'll see you next time.
See ya.
Bye.